Another key component of the exposure triangle, which are the three things that determine how bright a photo is or how properly it's lit, is aperture. And we've got the three things that make up the triangle are aperture, shutter speed, and ISO. So let's talk about aperture for a little while and talk about what it is and how you can control it to take control ultimately of your photos. What is aperture? What does it mean? Well, in simple terms, it means a hole. That's it. There are many things with apertures. A cup has an aperture. A pipe has an aperture. A bottle has an aperture. This water bottle here has an aperture. It's got a hole. And a fence post has an aperture. A hole in the ground has an aperture. Any aperture just means a hole. That's it. So don't let it get too complicated for you when people are talking about apertures and f-stops and everything. An aperture just means a hole, and that's it. A camera, remember, is at its core, it's a pretty simple piece of equipment. It's a box with a piece of film in it, and there's something that lets light into the box. And if you go back to the earliest cameras, that's all it is. It's just a big old box, and it's got at the back of it a piece of film, and there's something that lets light in, and that's the basics of a camera. Nowadays, the piece of film is digital, and there's a lot more complex operations that go into a camera. But really, that's all it is. It's just a box with a piece of film and something lets in light. The thing that lets in light is the lens. It's this thing here. If I take this off, this is the lens. And on a camera, the lens lets in light. And your camera might have if it's a DSLR, it might have what we call a kit lens. So it's a little longer than this probably, and it might have some markings on the side that say like 18 to 55. We'll get to that in a second. If it's a point and shoot, it's got a lens also. And if it's an iPhone, the lens is built right in. It doesn't protrude at all. But the lens is what lets in light. And how much light comes in is determined by the size of the hole in the lens, the opening in the lens. Remember, an aperture means hole. It means opening. And a lens has a hole in it that lets light in. Lenses, though, are pretty cool in that you can adjust how big the opening is. And that's where things really come into play in photography, is when we start adjusting the size of the opening. I'm probably not doing a very good job with my hands here, but you can make it smaller and larger. And I'll show you a demonstration of how that works on a lens here. But let's talk a little bit about what the size of the aperture means, what effect that has on your photos. So what does the aperture do? First, some background. The aperture is expressed in terms of what we call f-stop, which is the ratio of the size of the hole, or the focal length, in other words, the optical center of the lens, the distance from that to the piece of film. That's called the focal length, and that's expressed in terms of millimeters, so like 18 millimeters, 35 millimeters. That's called the focal length. The aperture is a ratio of that distance to the size of the opening itself. That's the f-stop. So I might have just said the aperture is. The f-stop is, or the how big you measure the hole of the aperture. It's a ratio of the distance from the middle of the lens, or the focal, the optical center of the lens, to the film. It's that compared to the size, or the size of the hole itself. That's what we call f-stop, and that is to explain the f-stop a little bit. Let's explain what this whole millimeters focal length thing is. So if your lens has a focal length of 18 millimeters or 15 millimeters, that means you get a wider angle of view and you can see more in your lens. So if you've got, say, the kit lens that comes with your camera and it says 18 to 55, when you put it at 18, if you turn the little dial until it says 18, or if you adjust on your camera manually so it says 18 millimeters, that means you're going to see everything. You're going to see, if you're in a room, you'll see the whole room. If you're outside, you'll see like the whole landscape. You'll see everything. The smaller numbers mean a wider angle of view. Larger numbers mean a smaller angle of view. So you might say it's zoomed in. And if you put your kit lens at 55, that means you're not going to see as much. You're not going to see this, you're going to see this. Some lenses have really long focal lengths, like 200 millimeters, 500 millimeters. Those are great for sports and wildlife photography because it zooms way in just on one little slice of what is available. It zooms way in, and you have a very small angle of view. We call this wide angle or telephoto. And on some cameras, you might see a W and a T for zoomed out and zoomed in. Wide, W means wide angle, T means telephoto. And I know we're getting off topic from just apertures, but it all works together here. On the kit lens, where it says 18 to 55, if that's what you're working with, 18 is the wide angle, 55 is the telephoto. 55 isn't really a true telephoto. Lenses aren't considered really telephoto until they get smaller, or until they get longer focal lengths like 85 or maybe 100 or 150. Those are really telephoto lenses, but you get the point anyway. The f-stop is the ratio of those dimensions, of the focal length and the size of the opening. That's the f-stop. It's sort of like fractions. So you know how 1/2, 1/2, is bigger than 1/4, 1/4. So when you're looking at a fraction, you might think, well, 1/2, 2 is a small number, and then 1/4, 4 is a bigger number, so a fourth should be bigger. No, we've all learned in like 3rd grade math that no, fractions, the smaller the bottom number is, the bigger the whole fraction is. So 1/2 is bigger than 1/4, is bigger than 1/8, which is bigger than 1/16. F-stops work like that too. An f-stop on your lens might be something like f1.8 or f2.4 or f2.8 or f5.6. The smaller the number, the bigger the opening is. And these seem like abstract concepts here. I'm going to demonstrate this in just a second here so you can actually see what this looks like. The construction of zoom lenses, if you have a zoom lens or a kit lens that zooms in, makes it harder to have a big opening. The way the optical elements and all the glass work together, it makes it hard to have a really big aperture. For instance, if you've got a kit lens in your camera, you might see on the side or the barrel of the lens some numbers that say like 18 to 55, 3.5 to 5.6. What that means is that when the kit lens is zoomed out, wide angle of 18 millimeters, the biggest the opening can be is f3.5. Again, if this seems complicated, I'm going to demonstrate this, so just hang with me. When your kit lens is zoomed in to 55 millimeters, and this goes for any lens, all lenses have a little description on the side of what the focal length and the f-stop is. But on a kit lens, if you're zoomed in all the way to 55, the f-stop might be 5.6. f5.6 means it's going to be a smaller aperture, a smaller opening. What that means in practical terms, though, is that a kit lens can't always let in as much light as a different lens. So even though it can zoom in and out, the trade-off is it doesn't have as big of an opening. It can't let in as much light as something like this, which is a prime lens, which means it doesn't zoom, but it can let in a bunch of light. This here is a 50 millimeter prime lens. It has an aperture of f1.8, which means it can let in a bunch of light, a ton of light. At 50 millimeters, its aperture is 1.8. Whereas if you have a kit lens in your camera, when you're zoomed all the way into 50 or 55 millimeters, the aperture is 5.6. That means it's a lot smaller. So when you're taking a photo with a kit lens, you often find yourself needing to use the pop-up flash because there's not enough light coming in from the size of the aperture, from the size of the opening. So you have to compensate for it by adding your own light. Let's look at this though, because this is kind of weird to talk about it unless we can actually see this. So on this lens here, I'm going to demonstrate what some of these numbers mean. If we look at this lens with an aperture of 3.3, and I'm going to make sure that I'm getting this right so you can actually see this. So 3.3 looks like this. All right, you see that hole? That hole that pops up? That is f3.3. It's hard to demonstrate on this here. That's a little better, 3.3. And that's the f-stop, f3.3. And it's the ratio of the size of that opening there to the optical center from the optical center of the lens to the actual film of the lens. It means f3.3. Let's go to f5.6. This is a much smaller aperture. See that? Much smaller. That's f5.6 on this particular lens. And it's going to be different depending on your camera and your lens and the size of the film in your lens, the digital film. But that's f5.6. And if we go even smaller, this lens has a smallest maximum or a minimum aperture size of f16, which looks like this. You can barely see it. See that? It's a tiny little hole. Lets in hardly any light at all. And the widest this can go is f1.8. And you're barely going to see anything on here. It's hardly going to move at all. Nothing. You don't even see it. The size of that aperture, of this opening in the lens right here, the size of that is huge on a prime lens like this, because the glass inside isn't moving back and forth to adjust the focal length. So you get a massive hole in your lens, which means you can let in a ton of light. So just a quick review, this is f1.8, this is f3.3 from before, a little smaller. If you got a kit lens, that's about as big as you can get. This is f5.6. Zoomed out or zoomed in on a kit lens, that's about as big as you can get. And then on this particular lens, we'll go to f16, which is pretty darn small. So that's an example of what all those apertures look like, the size of what those all apertures look like. The more light you have coming into your photo, the less sensitive your ISO needs to be, or the less sensitive your film needs to be to light. So if you've got a ton of light coming in, you don't need a piece of digital film in the back of your camera that is really that sensitive, because it's letting in so much light. If you're shooting with a larger aperture, let's talk about what it means to shoot at a larger aperture, like f1.8. That means you can let a ton of light in, so you can shoot at a lower ISO value, which means your photos will actually be higher quality. You'll let in more quality light, and you can look at I've got a different video on ISO that explains what that's about. If you have a larger aperture, you can also shoot at a faster shutter speed. You don't have to let your camera stay open very long. So your camera actually has the shutter on your camera, and I've got another video that explains shutter, but the shutter on your camera opens and closes to let in light for an amount of time that you tell it to. Or if it's on auto, the camera determines how long to open and close. If you're letting in a ton of light, you don't need to stay open that long. If you are shooting in a darker situation, you're sitting around a campfire, let's say, or you're taking photos indoors at night. If you've got a large aperture, you're letting in a ton of light, so you can shoot with a darker overall situation because it's so much light is coming in. You don't really need to use a flash. You also have the ability with a larger aperture to get a shallower depth of field, and I'm going to demonstrate that with a few examples in a minute here. But if you're a nature photographer and you would like to really isolate your subject, especially if you're closer up, if you've got like a kit lens, you can get a smaller depth of field. Now, if you're shooting with a 500 millimeter lens, that's not going to have a big aperture, but your subject is so far away, and the distance between your subject to the background is so far away that you're going to get a shallow depth of field no matter what, depending on how you control your photo. But if you've got a 50 millimeter prime lens, like what I just demonstrated, or a kit lens, you can get a shallower depth of field with a bigger aperture. If you've ever seen a photo of like a portrait of someone and there's stuff in the background that's blurred out, that's called bokeh or bokeh. And if you've got a bigger aperture, you can get more of that bokeh, which is that pleasing, blurry background look. So that's what it means to shoot at a larger aperture. What about a smaller aperture? Well, if you're shooting at a smaller one like f3.3 or f5.6, it means for a lot of lenses, your photos are going to be sharper, because due to the construction of a lens and the way that light comes in and is bent and curved by the lens, Most lenses are actually sharper at smaller apertures, so you're going to see more crisp details in your photos. In practical usage, you kind of have to zoom in a lot. If you're working with Photoshop or working with Lightroom, you won't necessarily notice the difference in photo sharpness between f1.8 and f5.6, but they are sharper generally at smaller apertures. Less light comes in, which is good in bright conditions. So if you're outside, your kid's playing soccer, or you're at the park, or you're watching wildlife, there's so much light available to you that you don't really need a giant aperture to let in tons of light. You can work with a smaller aperture. You can work with f5.6 or f8 or f11. It doesn't matter because there's so much light available to you, and you can still shoot at ISO 200 or 400, even though your aperture is really small. If you're shooting with a smaller aperture, it means that sometimes you want to do that because you want to leave your shutter open for a longer period of time on purpose. We talked about if you have a larger aperture, you can use a really fast shutter speed. If you've got a smaller aperture, sometimes that's a good thing because you want to leave your shutter open for a longer period of time and purposely let in more light. If you're trying to take a panning shot, like if you're following a race car across a track, and you want to leave your shutter open for a longer period of time, you can do that with a smaller aperture on your lens. You can also have a wider depth of field. So instead of isolating the one thing that you're focusing on, you can isolate more of the foreground and background. And depending on the photo you want, that's a good thing. So I keep talking about kit lenses versus prime lenses here. A kit lens isn't necessarily bad. It's just, it works in a different way than a prime lens. And if you understand how aperture works and the size of your aperture, how that works compared to ISO and shutter speed, you can get a lot of good photos with your kit lens. Let's take a look at some demonstrations though. I'm going to show you a few photos at different apertures so we can see what some of these concepts look like in a practical sense with depth of field and all the other things we're talking about here. So let's take a look at some example photos. What we're going to look at is 4 photos all taken of essentially the same scene and the effect that changing the aperture has on them. This first photo here was taken at an aperture of f1.8. These were all taken at ISO 100, so the film sensitivity was the same across the board. But the aperture changed, and because we're shooting in aperture priority here, the camera then compensated. In order to maintain a proper exposure, the camera compensated by varying the shutter speed, and I'll show you what happened with that in just a minute as we go through these. But right now, as we focus on aperture, this is f1.8. You can see the foreground here has been blurred out, and so has the background. It's all been blurred out, and the one thing that's really in focus is this set of berries right here. Everything else is really nice and blurry. This is what we call depth of field, or a shallow depth of field, meaning only this center portion is actually in focus. And that's what happens when you have a very wide aperture. And in this case, we're focusing with a wide aperture on something that's relatively close by. Now, if we were focusing with a wide aperture on some trees across the parking lot, everything would be in focus because what we're focusing on is so far away that even though there's a wide aperture, the focal point converges at the same relative distance as everything else, so it's not really going to matter. And the same if you're shooting with a telephoto lens, like if you're zoomed in with a 500 millimeter lens on a duck that's like across the street, that's also going to have a very shallow depth of field because the distance between the duck and everything else is so much more pronounced when you're zoomed in that far. But for this case, and for the case of most people with just a kit lens on their camera, if you are working with a wider aperture on a subject that's relatively close by, you're going to see this shallow depth of field. So if you want to get those really cool flower photographs that you've seen in magazines and stuff, one thing you can do is take your kit lens and zoom all the way into 55 millimeters and take a picture of a flower in broad daylight, and then you're going to have this nice shallow depth of field. Watch what happens as we move down the line here. This is f1.8, and we're going to use the same values that we talked about earlier in the video. Here is f3.3. We've still got a little bit of depth of field going on. This foreground is blurry, but we can make out there's some leaves here. We can kind of figure out what those are. And the background is also still blurry, but not as pronounced as the 1.8. which is here. Everything is really blurry except for just that one cluster of berries in the center. Here, more things are in focus. We have a broader depth of field, or a wider depth of field, and that's as a result of our shallower, or our narrower aperture, f3.3. If we go on down the line, here's f5.6, and this is the difference between a kit lens and a prime lens. If you shot this photo with a kit lens, the widest, when you're zoomed in at 55 millimeters on a kit lens, or about 50 millimeters, about the same thing here, the widest the aperture can go is f5.6. So if you were to take this exact photo, it would look like this. Whereas if I go back to the first photo in a second, this is what it looks like on a prime lens at f1.8. Bam! Huge difference. So you can see the advantage of having a wider aperture. And here we're back to 5.6. But let's go on down the line. If we go to f11, most things are in focus. We have a very wide depth of field, and f16, almost the entire photo is in focus, and we still have just a little bit of blurring way in the background on this air conditioner, and maybe a little bit in the foreground, but much more things are in focus. And one trade-off you'll notice is that, well, you might not notice it until I zoom in here and point it out, but as we start on the wide end, at the f1.8, this picture, in order to compensate for all the light coming in, the camera decided that it would shoot this at 1/1000th of a second shutter speed because it's letting in so much light. If we go down the line, this is f3.3, we're at 1/320th of a second. 1/100th of a second at f5.6. So the aperture is not letting in as much light. It's a smaller aperture, so to compensate, the shutter has to stay open for a longer amount of time. Here we're at 1/25th of a second at f11, and if we go to f16, we're at 1/13th of a second, which is not much time at all. This is in broad daylight, and there's just not much light coming in, so the shutter has to stay open for a longer period of time. And that's one of the trade-offs as you're working with Aperture and deciding what aperture to use for a given photo. You need to be aware that some of these trade-offs happen. One thing that you could also do is raise the ISO. If you wanted to shoot at f16 and have a quicker shutter, you could raise your ISO to 400 or 800 and it would snap it a lot quicker. On this day, it was fairly calm, and so most of the photo is really nice and sharp, even though it was 1/13th of a second. But if it was windy, you'd see these berries would be all nice, or not nice, you'd see these berries would be all blurry because they're moving around too much in that 1/13th of a second. Just to illustrate this one other way, I'm going to zoom into 100%. This is 1-to-1 magnification on the center cluster of berries. This is f1.8, 3.3, 5.6, 11, and 16. And I mentioned earlier, one of the advantages of shooting at a smaller aperture is due to the optics of your lens, the photos might actually be sharper at smaller apertures. And so the focus, what's in focus might be really in focus at a smaller aperture. And it's different for every lens, but you'll just have to play around with it. I'm going to show you another example, though, of what happens if you have a lens that is a smaller aperture and you still want to get that nice depth of field. So let's say you want to take a portrait of some people or your friend and you really want that nice blurry background. You can still do that. This photo was taken at f16, so really tiny aperture. And you'll notice the background is really nice and blurry. That's because there's so much distance between this piece of grass or whatever it is and the background. So if you want to take that nice blurry background shot that you might have seen in magazines with your kit lens, zoom in all the way to 55 millimeters and put a lot of distance between your subject and the background. This is probably about 60 feet between this blade of grass thingy and the house back there. Now, if I really wanted some nice bokeh, here's the same shot at f4. Not even f1.8, but just f4, and you'll notice it's almost too much. It's overkill. The blade of grass is so isolated, I don't even know what's behind it. I have no sense of context for what is happening in this photo. So all I see is a blade of grass or some seeds and a blurry mess. Maybe that's okay given the photo that you want to take, but this is kind of overkill on the aperture here. Maybe not quite so big. So this is just an illustration of why you need to learn how to control the aperture to get the photo you want to take. Just because you have a bigger aperture doesn't mean you should always use it. And just because you have a lens with maybe a smaller aperture doesn't mean that you can't get nice and blurry photos and sharp photos where one thing is in focus and one thing is not. Now that we've covered what aperture does, and we've looked at some examples of changing apertures on a lens, we've talked about shooting with a larger aperture, why you might want to do that, shoot with a smaller aperture, we've talked about all this stuff, and we've seen some demonstrations. How do you actually change the size of the aperture on your camera? Good question. If you've got a point and shoot, chances are you can't. The camera determines automatically how big the aperture should be. If you've got a DSLR like this is a D7100, and you'll see on the side it's got this dial here where it says M, A, S, and P. And I'm going to see if I can get really close. M, A, S, and P. S means shutter priority, which means I'm going to set the shutter speed and the camera's going to figure out the rest. But I'm going to change it to A, which means aperture priority. If you have a Canon or a Pentax, it might say TV or AV. You're going to want to set yours to AV, which means aperture value. Then you're going to, once it's in A, you can put it on M if you want. M is full manual, but that's a little more intimidating if you've never done that before. Once it's in A, then you can use the dials on your camera. Most cameras have a little dial that's up on the top if it's a Canon. It's maybe on the back, like this is right here on the back, or this has a front dial. There's a dial somewhere, or maybe it's even a selector that goes up and down. But somewhere on your camera, once it's in A or AV on a Canon or Pentax, then you can change the size of the aperture. So if I put it in A, then I'm going to see if I can demonstrate this again here. If I put it in A, I can change the size of my aperture using the front dial here. So I'm changing it from, it's now f2.8. Now it's going to be f2, f1.8, f4, f8. And you'll notice the next number over, that 10, 8, 6, 4, that's the shutter speed. What's happening here is my aperture, now we're at f16. Remember how I showed you f16 is super, super tiny? That means the shutter is going to have to stay open longer in order to let in enough light. It's going to stay open for 1/3 of a second, which is a really long time. If I lower my aperture, or raise my aperture to f1.8, now the camera can, the shutter can stay open for 1/250th of a second in order to get the same photo that it would have otherwise at f16. Sorry, it's going back and forth here. But now we're at f1.8, and it's a 250th of a second. This is at ISO 400, which you can change on this camera with the bottom number, or bottom dial. So you see the effect that changing the aperture has. If I change it to f5.6, now we're at a 20th of a second. A 10th of a second. So as you change the aperture, other parameters on your camera change as well. If you've never tried this before, if you've never shot with controlling some of these elements, like controlling the aperture, put it in A. If you've got this little dial, put it in A or AV and head outside and play around with it. What you're going to find is that as your aperture is bigger, your shutter is not going to be open very long. It's going to just open for like a snap of a second. If you make a smaller aperture, your shutter might have to stay open a little longer, depending on how much light is available. But play around with it and look at the photos that you take at different apertures, and look at what happens to the background and the foreground and things that are blurry, and things that if your subject is really sharp, or if your subject is maybe a little blurry because your aperture was small and you had to leave your shutter open for a longer time. So if you've never tried shooting in with some of these manual controls, give it a shot. It won't hurt anything, and you'll learn a lot about your camera in the process. Put it in A in aperture value and play around with the aperture. And you can even look at your camera and look at the size of the opening that you're getting when you take some of these pictures, so that you can start to see in practical terms what this means. This is on every camera, whether you've got a Micro Four Thirds or even an iPhone or an Android phone. All cameras work with the same basic principles of exposure, of aperture, shutter speed, and ISO. And once you learn to start controlling them, you'll learn to take much better photos than you would otherwise in auto mode. So that's it. Again, check out my other videos. If you have any questions, leave them below. Leave a comment below, and I'll do my best to answer them. And remember that no one can tell you that the photos you're taking are bad or good. It's all in what you want to do. So just because you don't have the fanciest camera, $1,000 DSLR, doesn't mean you can't take good photos. What it does mean, though, is that you should learn to play around with and ultimately learn to control the different parameters in your camera to take the photos that you really want to take. Thank you very much.